Hello and welcome to Pat Problems with Helena and Kat. My name is Kat, I'm the Physics Access Officer at Oxford University, and this year Helena and I have selected 8 problems from the 2015 Pat paper to share with you over the summer. A word of warning before we start. The 2024 Pat paper is going to be an on-screen multiple choice format. That means that while all the techniques which Helena and I are showing you and while all of the problems that we do are highly relevant, in the 2024 paper when you are done you will be selecting an answer on screen rather than underlining to show the examiner that your working is finished. If you would like to come along to a webinar all about multiple choice technique and what the 2024 PAT would look like, we are hosting a webinar as part of our Preparing for the PAT course on the 11th of September 2024. You can sign up for that on our Preparing for the PAT page. Without further hesitation, however, I'd like to take you through the first problem which I have selected, which is this question. Evaluate the integral between the limits of 4 and 6 of 2x minus 6, x minus 4, x minus 2, all to the power of 1/2 dx. Now, whenever I'm evaluating an integral, I have a mental checklist which I work through. And one of the things on that checklist to look for, quite far down, is do I have a function with its derivative close by which would allow me to use change of variable. And in this case, I absolutely do, even if at first that isn't perfectly clear. Let me show you how that happens. So if I allow y to equal these second two brackets, the x minus 4, x minus 2, and I'll pop that in there, x minus 4, x minus 2. And if I multiply out those brackets, I come to y equals x squared minus 6x plus 8. The derivative of this function, dy by dx, is 2x minus 6, which is this first bracket out of 3 in the original expression. So this original integral is a function with its derivative close by, allowing me to use change of variable. And just to make that nice and neat, I'll rearrange it to dy is 2x minus 6 dx, so that we can see exactly what I'm going to substitute in when I do this. That just leaves me with our limits. At the moment, my limits are 4 and 6, and they are in terms of x. I'd like to put those in terms of y, because I'm going to evaluate my integral with respect to y using change of variable. That's lovely and simple to do. I'm just going to pop in if x is equal to 4, y would equal 4 squared minus 6 times 4 plus 8, which would come out in the end as y is equal to 0. And I'll do my upper limit as well. If x is equal to 6, y is equal to 6 squared minus 6 times 6 plus 8, giving me an upper limit of 8. I'm now ready in this case to completely redefine my integral in terms of y, so that instead of this long integral, I'm going to be evaluating between 0 and 8, just the integral of y to the half dy, which is significantly simpler, the whole point of change of variable being to make your life easier. And that's going to come out to 2y to the 3 over 2 all over 3 between 8 and 0. If I substitute those through, I'm going to have 2/3 of 8 to the power of 3 over 2, take away 0, which is 2/3 of 8 to the power of 3 over 2. When we are simplifying an answer like this in a multiple choice paper, we can have a quick look at what the multiple choice answers are and see how far we need to simplify to be able to match. If this were a longer question, for example, if you were asked it in an interview, it's really a personal choice how far you would evaluate this. I would break down the 8 to the 3 over 2 into 8 to the 1 times 8 to the half, using the fact that when I multiply powers together, I add the powers, simply because that would get me down to 16 over 3 times root 8, which is nice and simple. Root 8 is root 4 root 2, giving me 32 over 3 root 2. As I say, you'd be looking at the multiple choice selections in the 24 paper and finding out which one perfectly matches before you make the decision of how far you have to simplify that. That is question 4 from the 2015 paper. Quite a nice 5-mark maths question. I hope that's useful, and we'll see you again next week with our next selection from the 2015 paper. Thank you very much.